Hello, ladies and gentlemen. Let us begin. Let's go over study guide for advanced algebra, chapter 6. All right, let us begin. Here we go. Section 6.1, evaluating nth roots and rational exponents. Express using fractional exponents, reduced to lowest terms if necessary. All right, so we've got the seventh root of r to the fifth power. So the 7 will be the denominator, and the other number, the 5, will be the numerator. So we just need to write r to the 5/7 power. That's it. Number 2, same thing. The 3 is the root, okay? The cubic root of t. So the 3 will be the denominator, and the numerator will be a 1. Done. Number 3. All right, well, first I'm going to change the root to rational exponent. So I'm going to rewrite this. I'm going to do a little scratch work off to the side here. So I've got 3 over q to the 1/4 power. All right. Well, we are going to go ahead, and I know we're not supposed to have negative exponents, but if we're going to express this using fractional exponents and we're trying to be consistent with the way this all looks, we're going to move the q to the 1/4 up. So remember the little saying, cross the line, change the sign when you're dealing with exponents. So I'm going to rewrite this as 3q to the negative 1/4 power. Okay, and I'm going to leave my answer like that. Okay, I'm going to do the same thing to the next one. I'm going to first rewrite it with a rational exponent. Okay, and again, I know we're not supposed to have negative exponents, but what we're going to do is we're going to move that up, cross the line, change the sign, and here is our answer. All right, that part is done. Let's move to the next part. Express using radicals, roots. Leave answers in simplest radical form. All right, so you notice the 5x is all inside the parentheses. So we're going to make our radical symbol. The 5x all goes inside. The root number is the 4, so I'm going to put the 4 right here. And this is really important. Since the 5x is in parentheses, then I should put parentheses around it inside the radical. And then the 7 is the exponent, and I'm going to put that right there. Okay? So let me make that 7 a different color so we can see it a little better. So the 7 is right there. All right? Let me rewrite that again. So we've got the 4th root of 5x to the 7th. All right. Number 6. All right, so we're doing the opposite of what we did in the first part. So we are going to rewrite this, and we're going to first cross the line and change the sign. So I'm going to do a little scratch work first. And remember, the numerator is now a 1. All right, now I'm going to write my final answer using the radical. Here we go. And the radical is a 4, fourth root. And oops, that's a 3. Okay, this is a 3. Kind of hard to see it. That's a 3. So that means I need to put a 3 right here. All right, so make sure that you have the 3 on there. And number 6 is done. Let's go to number 7. Okay, there's no negative, so no need to cross the line, change the sign. So we're just going to go straight to this. We're going to put the y inside, we're going to put the 3 here, and we're going to put the 2 there. Boom, we're done. Okay, number 8, again we got a negative exponent, cross the line, change the sign. Make sure I got my numbers right, 4/5. All right, now I'm going to write the answer. The 5 is the root. And then z to the 4 on the inside. So 1 over the 5th root of z to the 4th. All right, so that is what section 6.1 was about. That's what you need to know for the test. All right, chapter 6.2. Evaluate the expression using a calculator. Round your answer to the nearest hundredth. Change from radical expression to a fractional exponent first. All right, so I'm going to rewrite this as 7,500 to the 1/4 power. Now, when I type that into the calculator, I'm going to type 7,500. I'm going to use the caret key for my exponent. And if you have an old calculator, make sure you use parentheses to the 1/4 power. All right, squiggly equal sign for approximately. So let's go to the calculator. 7,500. Okay, to the 1/4 power. Whoops. You do that again. Okay, 7,500 to the 1/4 power. So it's approximately 9.31. Okay, the hundredths place would be 2 digits past the decimal, so 9.31. Okay, that's it for that one. Okay, number 10. So this is where we need to remember our perfect cubes. We're going to need to split the 135 up into 2 numbers. Okay, so let's review our perfect squares. We've got 2 to the 3rd, which is 8. We've got 3 to the 3rd, which is 27. We have 4 to the 3rd, which is, I believe, 64. Okay, well, which one of these will divide 135 or go into 135? Well, 8 will not, because 5 is an odd number. 64 will not, because, again, 5 is an odd number. So we will not use those. All right, so it must be 27. So let's double check with the calculator. So I've got 135, and I divide it by 27. And yes, the other factor is 5. So 27 times 5. Now, what is the cubic root of 27? Okay, well, just look back at what we did right here. So the cubic root of 27 is 3. So our answer is 3 cubic roots of 5. Again, this 3 came from over here. The cubic root of 27 is 3. All right, number 11. Here we need to know our perfect squares. Okay, the square root of 250, so you need a perfect square that goes into it. Let me just review perfect squares. All right, which of those perfect squares will go into 250? Pretty easy, I think. I believe that would be 25. 250 divided by 25. Yeah, 10. All right. And the square root of 25 is 5, so our answer is 5 square roots of 10. All right, number 12. So we have the fifth root of negative 243. All right, well, fifth roots, let's just go through a few. So if 2 to the fifth power, well, let's check that out. 2 to the fifth power is 32. Whoops. 3 to the fifth power Whoa, look at there. It's 243. All right. So that means it works exactly. Okay, so, but there's a negative in front of it. So negative 243 to the 1/5. Okay, it must be going to turn out here, so let's check it out. Negative 243 to the 1/5 power. Hey, look at that, negative 3. So that one turns out to be exactly negative 3. Okay, number 13, I'm going to rewrite that. Okay, remember that 18 is the exponent on the x. It's inside the parentheses with the x. And then the sixth root is 1/6. And if you remember, this is where we multiply exponents. And 18 times 1/6 is 3. So the answer is x to the third. All right, let's go to page 2. Simplify each radical expression. So we have a plus sign in between. So we've got 6 times the cubic root of x plus 2 times the cubic root of x. So these are the same. So we are going to simply add them together. So 2 plus 6 is 8. And then the cubic root of x. Okay, they are like terms. You add them together. So 6 plus 2 is 8, and then the cubic root of x. That's it. Number 15, there's a little bit more work. Okay, number 15, we cannot add them yet because they do not have the same square root. Okay, square root of 75 and the square root of 147. So we need to split it up. So the 175, let's see. We're going to split that into two numbers. All right, let's see. What perfect square goes into 75? 25 times 3. Okay, 25 times 3 is 75. All right, what perfect square goes into 147? Let's see. I believe that would be 49. Let's check it out. 49. So 147 divided by 49. And oh, look at there. It's 3. Its partner is 3. All right. So 49 times 3. Well, the square root of 25 is 5. So 5 square roots of 3. Plus the square root of 49 is 7. So 7 square roots of 3. Oh, we can now add them together because the radicals are the same. So 5 plus 7 is 12. So our answer is 12 square roots of 3. All right, number 16. Simplify as much as possible. So let's see. We're going to split this into, first we got to split the 20. So what perfect square goes into 20? I believe that would be 4. 4 times 5 is 20. Now, we need to split up the x to the 5th. So, how do we split up x to the 5th? Now, remember, there's a 2 right here. We don't write it, but there is a 2 right there. So we need to split this 5 up into 2 numbers. One number needs to be divisible by 2, and the other one needs to be smaller than 2. Well, there's only 4 and 1. So 4, that one's divisible by 2, and 1, which is smaller than 2. So we split up the 5 into 4 and 1. All right, so let's see. Now, the square root of 4 is 2. Okay, that takes care of the 4. Now, the square root of x to the 4th, remember that's the same as x to the 4th to the half. 4 times a half is 2. So that's x squared. Okay, so that takes care of that. And what's left? The square root of 5x. There's our answer. 2x squared times the square root of 5x. All right, number 17. If you recall, one of the rules in algebra is you are not allowed to leave radical symbols in the denominator. So we're going to have to get rid of the cubic root of 2. So here we go. So let's see. Let's use purple this time. All right. So we've got 5 over the cubic root of 2. Now, we need to eliminate the cubic root. So we're going to have to multiply the top and bottom by something so that we can get rid of the cubic root. All right, well, we need to review our cubic roots a little bit. Here we go. So off to the side here, I'm going to do some cubic roots. So again, I know that 2 cubed, okay, and that's a good indication because that's a 2. 2 cubed is 8. So in order to take the cubic root of that to get back to 2, I need an 8. So I need this to be an 8. Okay? So the question is, what do I multiply by to get 8? Well, 2 times what equals 8? Well, that's easy, 4. So I do 4 and 4. Again, you got to multiply the top and bottom by the same. So now this is 5 square roots of 4 over the cubic root of 8. But remember, the cubic root of 8 is 2. So our answer to this problem ends up being 5 cubic, well, let me rewrite that a little bit better. Okay, I'm going to go over here. There's more room. So 5 cubic roots of 4 over 2. That is our answer. Okay, 5 cubic roots of 4 over 2. Okay, look at that one carefully, think about it, rewatch it if you need to. All right, so that was section 6.2. Let's move on to section 6.3. All right, given that f of x equals 3x to the 3/2 power, g of x equals x squared, h of x equals -5 times the square root of x to the cube, complete the following computations. Well, this first one says we are going to multiply f and g together. So we're going to take f of x times g of x, which is x squared. All right, well, there's a 1 here. So 3 times 1 is 3. All right, so now what we're going to end up doing is we're going to be adding the two exponents together. Okay, 3/2 plus 2. So let's see. 3/2 plus 2 is 7 over 2. And that's our answer. So when we put those two together, we get 3x to the 7 over 2. Okay? If you have to add those two together by hand, let me just do a real quick review of that. So 3 over 2 plus 2 is 3 over 2 plus, remember you need a common denominator, so you would need to change the 2, put a 2 on the bottom, but you got to keep it a 2, that would be 4 over 2, right? 4 over 2 is 2. And then 3 plus 4 is 7 over 2. So that's how you can do it by hand. Okay, number 19, we are going to plug the f of x into the g of x. So the f of x is going to get plugged into the g of x. So we are going to replace the x with, all right, so I replace the x with 3x to the 3/2 power. Well, following the exponent rules, we have to now do 3 squared. And then remember here, we multiply the exponents together. 3/2 times 2. Okay, if you need to use a calculator, use it, or multiply it by hand. 3/2 times 2 is 3. So our final answer is 9x cubed. All right, next problem. We're going to put g into f. So we're going to take the g and put it into f. So we're going to go 3. We're going to replace the x with x squared. Again, look at it carefully. We're replacing the x with x squared. All right, well, in this problem, nothing happens to the 3 because it's on the outside. But again, here we're going to multiply the 2 and the 3/2 together, and that will be the same as problem 19. 2 times 3/2 is 3. So in this problem, the answer is 3x cubed. All right. And then number 21, we're going to add the f of x and the h of x. So we're going to add this and this. So here we go. So we've got 3x to the 3/2 plus negative 5 square root of x to the 3rd. Well, I have to rewrite that, ladies and gentlemen. Okay? 3 x to the 3/2 plus negative 5. We've got to rewrite the radical. So that would be x. Now remember, there's a 2 right here. So that would be x to the 3/2. Since they are the same rational exponent on the variable, we can add those two together. So 3 plus negative 5 is negative 2. So our answer is negative 2x to the 3/2. All right, let's do another practice with the next one. Here we go, number 22. We're going to add the two functions together, m and n. So we're going to add these two together. All this is combining like terms. So 3x and 2x makes 5x. And negative 2 and negative 5 makes minus 7. And that is our answer. Okay, the next two, it says multiply them together. Well, that looks like FOIL to me. Okay, first outside, inside, last. All right, number 24. As soon as I can get this thing to move, there we go. All right, number 24, too far. 24, we are going to plug the function n into the function m. So we're going to take this one and we're going to plug it into this one. All right, so here we go. So we've got the 3. We're going to replace the x and then the minus 2. So we're going to replace the x with 2x minus 5. All right, a little bit of algebra. Distribute, combine like terms. Here we go. And we're done. Okay, we're going to do the same thing with the next one, except we're going to go the other way. We're going to take the function m and we're going to plug it into the x for function n. All right, so we've got the 2. We're going to replace the x. And we're going to replace the x with 3x minus 2. Distribute, combine like terms. All right, that page is done. Let's keep going. Next page. Find the inverse function given f of x equals 3x minus 2. All right, let's go through the steps. Okay, step 1, remember, we switch x and y. Step 2, solve for y. All right, here we go. So, I'm going to rewrite this with a y in it. Okay, now I'm going to make the switch. Now I'm going to get y by itself. I'm going to solve for y. So I'm going to go through the steps. Okay, I just flipped it around and said 3y equals x plus 2. And last step, divide by 3. So the inverse function is y equals 1/3 x plus 2/3. Now, we should put that into function notation. So I'm going to rewrite that and put the inverse in for the y. So this is what it should look like. Okay, so with the f to the negative 1, that is telling us that that is the inverse function. All right, 27, we're going to do the same thing. We're going to find the inverse, but this is g of x. Here we go. So I'm going to go ahead and rewrite this. Switch x and y. Okay, now we have to solve for y. So the first thing I'm going to do is subtract 5. Whoops. Subtract 5. Okay, so I'm going to rewrite this. Okay, I'm going to flip-flop here. So I'm going to rewrite this as okay. Next step, divide by 2. So we have the cubic root of y equals x minus 5 over 2. All right, now how do you get rid of a cubic root? Okay, well, to undo a cubic root, we have to cube both sides. And make sure you put the right side all in parentheses. Okay, so the cubic root and the cube cancel each other out, so we're left with y. And then we just leave that x minus 5 over 2 all cubed. We just leave it like that. Okay, and then I should rewrite that, so I'm going to cross this y out and put the inverse. It should be g to the negative 1 x. So the inverse of g equals x minus 5 divided by 2 cubed. All right, 28. Are the two functions inverses of each other? Okay, so what we're going to do is we're going to plug one function into the other. If we end up with x, then yes, they are inverses of each other. All right, so here we go. So I'm going to go ahead and plug this one into this one. Okay. if one works, the other should work. So I'll show both of them. I'll do both of them. So I'm going to plug first this one into this one. So I'm going to replace the x with the cubic root of x minus 2. And again, what do the cube and the cubic roots do to each other? Hey, they cancel each other out. So we're left with, and lo and behold, the negative or the minus 2 and the 2 cancel, so we're left with x. So yeah, that's a good thing. So yes, that is showing that that is an inverse. Okay, I'll just show it the other way too. So I'm going to go backwards. I'll do this one in red. So we're going to take this one and we're going to plug it into that one. So we're going to replace the x with x cubed plus 2. Well, the 2's cancel each other out. So we're left with the cubic root of x cubed. And the cubic root of x cubed is just x. So either way works. So yes, they are inverses of each other. Okay, number 29. Let's check that one out. So first I'm going to plug the 2x minus 3 into the other one. So here we go. So I got 3. And I'm going to replace the x with 2x minus 3. Distribute. And I can stop right now. No, they are not inverses of each other. We did not end up with x. Okay, I don't need to do anything else. Okay, it does not equal x. Therefore, they are not inverses. All right, we are done with that. Let's move on to 6.5. Okay, number 30. Graph this function, y equals the square root of 2 minus 3. All right, well, if you know the little trick, okay, the starting point, ladies and gentlemen, is going to be left 2. And this minus 3 means down 3. So this graph is going to start right there. Left 2, down 3. So I could make a little table here. So negative 2, 3 is going to be the starting point. Well, I could plug some other numbers in and check it out. If I plug negative 1 in, okay, well, think about this. Negative 1 plus 2 is 1. All right, so let's just do this. Negative 1 plus 2 minus 3. That's going to be 1 minus 3, which is going to be negative 2. So, negative 1, negative 2. Oops, let me do that again. Negative 1, negative 2. Come on. Sorry, my Promethean board is being slow. There we go. Negative 1, negative 2. Okay, the next logical one. Okay, if I put a 0 in there, that's not going to be a perfect square. Okay, I want numbers that work nice. So I'm going to go with 4 next. Actually, not 4. I want it to become a 4. I'm going to do 2 next. Okay, so let me move this up a little bit. So the square root of 2 plus 2 minus 3. So that would be, and then that would be, so that becomes negative 1. So 2, negative 1. Okay, let's see, what else would work? Okay, to get a perfect square, okay, again, I'd like this to be a perfect square. So what would give me 9? 9 is the next perfect square. Well, that would be 7. 7 plus 2 is 9. The square root of 9 is 3. Minus 3 is 0. So 1, 2, 3, 4, 5, 6, 7. There's my graph. Okay, it has one arrow and one endpoint. Okay, you could also, if you have the fancy calculator, you could also type that into your calculator. Okay, you could type in the square root of the x plus 2. And then the minus 3. Make sure that the minus 3 is not under the square root. You could go to the table, and you can see, starting right here, negative 2, negative 3 works. Negative 1, negative 2 works. 2, 1, negative 1 works. Skip the decimals. 7, 0 works, and that's all that's going to fit. All right? Now, what is the domain? Okay, well, remember, domain is x. And the x starts at negative 2 and gets bigger. So x is greater than or equal to negative 2. Okay, what is the range? Okay, well, the range starts at, whoops, this is a negative 3. My bad. That's a negative 3, folks. Negative 3. Sorry about that. Did I write it correctly over here? Oh, yeah. Negative 3. Okay, so my range starts at negative 3 and gets bigger. So y is greater than or equal to negative 3. Sorry, I missed that sign. I plotted it right, but I missed the sign. All right, so there's number 31. Let's go to the next page. Let's do another one. So I won't make the same mistake this time. So here's my table. My starting point is negative 5, negative 6. Negative 5, negative 6. Okay, while the domain, I'm going to just go ahead and do my domain and range right now. So my domain is going to be bigger than or equal to negative 5. And my range is going to be bigger than or equal to negative 6. Now, if you look back at the last one, there is a pattern to this. Okay, if you have Shuck, or he probably showed you this, hopefully. So the trick here is the next dot is just going to be up 1 over 1. Okay, the next dot, if you look at the pattern of the last one, it's going to be up 1 over 3. And then the next one is going to be up 1 over 5. You're going, huh? Why is that? All right, well, let's do this. So if I put negative 4 inside, we get 1, right? 1 minus 6 is negative 5. And that's the second dot. Okay, then again, I want a perfect square here. So the next number that gives me a perfect square will be negative 1. Negative 1 plus 5 is 4. The square root of 4 is 2. 2 minus 6 is negative 4. That was up 1 over 3. Same pattern as the last one. Okay, and then the next number that gives me a perfect square is, what would I add to 5 to make the next perfect square? Well, it would have to be a 4, because that's 9. And then square root of 9 is 3. So 4, negative 3. 3 minus negative 6 is negative 3. Right? Look at the calculator. Try it there. All right, moving on. 34. All right, to solve this one, you got to, well, this one's easy. All you need to do is take the square of both sides. So just square both sides. X equals 64. Done. Okay, this one we are going to get rid of the cubic root, cube both sides. X plus 2 equals 8. 2 cubed is 8. Subtract 2, 6. Number 36, square both sides. Get rid of the square root. Solve for x. Leave this one as a fraction. Okay, 37. First, we gotta get rid of everything around the radical symbol. We gotta isolate the radical symbol first. So we gotta get rid of two things first. Add 26. Divide by 3. Square both sides. X is 16. Okay, on this one, the radical is already isolated, so we're just going to begin by cubing both sides. Three cubed is 27. Okay, now it's just a matter of solving for x. Subtract 2. Divide by 5. All right, 39 and 40, a little bit more work. Here we go. So you will notice in number 39 that the radical is isolated on the left side. So we need to get rid of it. And when we get rid of it, we're going to square both sides. And when you do the right side, you need to put it in parentheses. So the left side is, and then the right side, we're going to end up foiling because x minus 5 squared means x minus 5 times x minus 5. So we're going to have to foil that. All right, here we go. Combine like terms. Now, in order to solve that, we're going to have to get it equal to 0. So we are going to subtract x and add 3. So this is what we get. Okay, now we have to factor. Let me move the board. Factors of 28 that add up to negative 11. That would be negative 4 and negative 7. Okay, two solutions, 4 and 7. However, remember we must check for extraneous solutions. So that means we have to check both answers. All right, so I'm going to check the 4. So I'm going to plug the 4 in. I end up with the square root of 1 equals negative 1. No. That is not true. The square root of 1 will not equal -1. So this is an extraneous solution. Okay, but I need to check the 7 because it's possible the 7 is also extraneous. So let's check 7 out. Is the square root of 4 equal to 2? Yes. So 7 is the only one that works. All right, number 40. We're getting there. Okay, we have a square root on both sides. So we're going to end up, to get rid of the radicals, we're going to square both sides. So, oh, this one's easy. Okay, now I'm going to subtract 2x from both sides. I'm going to add 2 to both sides. And divide by 2, and I end up with now, the question is, does it work or is it extraneous? So let's check it out. So I've got the square root of negative, whoops, that's not a -2, sorry about that. So 2 times -1 minus 4. That would be the square root of -6. Okay, let's check out the other one. Let's see, we got 4 times -1 minus 2. That would be the square root of negative. Yeah, that one is okay. That one works. We got the square root of -6 on both of them, so that one does work. All right, moving on. All right, review, factoring. Here we go. So the first one, factors of -4 that add up to -3. Okay, well, that should be a pretty easy one. X minus 4 and x plus 1. So x minus 4, x plus 1. Okay, number 42 is a special case. It is the difference of 2 cubes. So in this scenario, let's see, the cubic root of x cubed is x, so I'm going to put an x right here. The cubic root of 8 is 2, so that is a 2. So following the pattern, so now this would be x squared. A times b, well, that would be 2 times x, so this is 2x. And then 2 squared, following the pattern, 2 squared, the b is squared, that would be 4. That's it, we're done. Okay, that one was a difference of 2 cubes. Number 43. Always look for a GCF, and there is one, so we're going to pull it out. That would be 3x. And what's left? X squared minus 3x minus 4. Well, look at that. It looks just like 41 now. So the final answer is 3x times x minus 4 times x plus 1. Same thing with number 44. Pull out the GCF. So let's see. The GCF is 5x. What's left? X squared minus 2x plus 3. Now factor that. Factors of -3 that add up to, or positive 3 that add up to -2. Well, that'd be -1 or -1 and -3. There we go. Number 45. Pull out the GCF. Okay, GCF is 2. Now we have a difference of 2 squares. Okay, difference of 2 squares. Remember, one's going to be a minus, one's going to be a plus. Square root of x squared is x. Square root of 16 is 4. There we go. Pull out the GCF, you ended up with a difference of 2 squares. All right, next one, same thing. We're going to pull out a GCF. Now on this one, we're going to want to pull out a negative because there's a negative in the front. So we're going to pull out a negative. 2x. What's left? X squared minus 7x plus 12. Factors of 12 that add up to negative 7, that would be negative 3 and negative 4. So x minus 3 and x minus 4. Okay, 47. You notice there are 4 terms in it. When there are 4 terms in it, that's when we want to factor by grouping. Okay, remember that? So we're going to group the first 2 together, and then we're going to group the last 2 together. So what's the GCF of the first 2? That would be x squared. What's left? X minus 2. Okay, well, if you remember factor by grouping, we're going to want to end up with the same binomial when we pull out the GCF. So we're going to want an x minus 2 again. Well, what do we pull out to get that? That would be a minus 4. Okay, then the next step is we pull out. They both share x minus 2, so I'm going to pull out x minus 2. And what's left? X squared minus 4. Now, x squared minus 4 is a difference of 2 squares, so I'm going to finish this off and do the difference of 2 squares, which would be x minus 2 again, and x plus 2. That's our answer. All right, 3 left. So again, I always start by pulling out a GCF. In this problem, the GCF looks like 8x squared. And when I pull out an 8x squared, all I'm left with is x minus 3. Wow, that was it. We're done. Nothing more to do. 49. All right, x to the 4th minus 64. Well, that's a difference of 2 squares, so let's start off. X squared minus plus square root of 64 is 8. Okay, well, what do you notice about x squared minus 8? Oh, look at that. That's another difference of 2 squares. Now, the x squared plus 8, there's nothing you can do to that. But the x squared minus 8 can become x minus. Well, wait. I'm wrong. I goofed. You cannot. That is not a difference of 2 squares. Okay, I am silly. All right, whoa, I don't want to erase it. That is it. We can't do anything more to it. That is not a difference of 2 squares. So we have to leave it. That's it. We can't do anything more. Okay, almost done. Last one. This is a difference of 2 squares. So, whoa. Okay, now I don't want to blow your minds away, but the first one, x cubed minus 1, that is a difference of 2 cubes. And the x cubed plus 1 is a sum of 2 cubes. That means, ladies and gentlemen, we're going to use both of these. Whoa. All right. So let's start with this one. Okay, I'm going to color code these. I'm going to switch this one to blue. All right, so I'm going to do the orange one first. Here we go. So this is going to be, I'm going to make that a little bit smaller here. So this is going to be x minus 1. X squared plus x plus 1. Again, I'm following the pattern up above. Look up there for that one. Okay, and then this becomes x plus 1, x squared minus x plus 1. All of that is our answer. Wow. All right, good luck on your test. I hope that was helpful.